We're going to be writing exponential equations in the form of y equals a times b to the x. A is your initial value, whatever we're starting with, and b is your growth rate, or I guess it could be your decay rate, whatever you're multiplying by each time. The bear population increases at a rate of 2% each year. There are 1,573 bears this year. What's your initial value? All right, what are we starting with? We're starting with 1,573 bears, and our growth factor, sometimes people might say, hey, we're growing by 2%. Let's write 2% right here. Well, that's kind of right, but if it's just 2%, then that's going to be decaying. You're going to be losing a lot of bears if you're multiplying by 0.02 each time. So if we're increasing, that's one of those where you say 1 plus 0.02. And if you were decreasing, then you would say 1 minus 0.02. But we're growing. The bear population, unfortunately, is increasing by 2% each year. Oh my. That would be 1.02 is what we're going to use for our formula down here. When we write an equation, we'll have y equals a times b to the x. That's 1573 times 1.02 to the x. And if we want to know how many bears there will be in 10 years, all I'm going to do is take 10 and plug it in for that x. So if we were going to be all fancy, we could say f of 10 equals 1573 times 1.02 raised to the 10th power. I would punch that into my calculator, and it would give me about 1917 and some decimals for bears. I don't know if we're allowed to have decimal bears or not. So 1917 is how many bears we're looking at. The number of student athletes at OCHS is 200 and is increasing at a rate of 7% each year. Once again, we're increasing. We're starting with 200, and the growth factor, since we're increasing, we're going to say 1 plus 0.07. That b value will be 1.07. My equation would be y or f of x, however you want to write that, equals 200 times 1.07 to the x. So once again, you could write it like y because that's what our formula says. Either one works. And if you want to know how many student athletes OCHS is going to have in 6 years, you would take 6 and plug it into that formula right there. You'd have 200 times 1.07 to the 6th power instead of just x. And that would give you 300.14, I think. We're just going to call it 300 student athletes after 6 years. The car valued at $45,000 depreciates at a rate of 6.5% each year. This one's different because our car is depreciating in value. It is losing value. We are starting with $45,000 car, and we're not going to plus. We're going to subtract 1 minus 6.5%. So 6% would be that, and then 6.5%, we're just going to throw that 5 at the end of it. So that's going to be, 0.935. So when we write our equation, we'll have y equals 45,000 times 0.935 to the x. And how much will our car be worth in 2 years? All I'm going to do is take 2 and plug it in for x right there. That'd be 45,000 times 0.935 to the 2nd power. And our car is going to be 39,340, I believe, and change. Next, we're looking at a table. Actually, let's take a step back here. All right, let's look at these. I've got this pulled up right here for us. We've got our student athletes right here. The one that we talked about with our example with student athletes at OCHS. It's increasing by, I think it said like 7% each year. And our initial value is 200. Well, if I look at this graph, I can tell that it is going up the roller coaster like that. I know that it's increasing, that it is an exponential growth. And we started at 200. Notice that that is our y-intercept. And that is where we are going to Start. So that's important. That's your initial value. That's where you're starting your y-intercept. If I were to look at the bear population, 1573, it's increasing. I know that it's going up the hill. But how many bears did we start with? Well, we started with 1573. Once again, that's my y-intercept. Whatever you're starting with, where x equals 0, that's what you're starting with. If I were, hey, how much was my car worth to start with? Look at this. It's a decay graph. It's going down the roller coaster like that. Car was, what, 45,000? I got to zoom way out for this one. Right there. Is that my y-intercept? Look at that. Okay, let's go back over here. So when I have a table and I got to write the y-intercept, the rate, and the equation for that, the y-intercept, well, that's where x equals 0. Y-intercept's 4. And the rate in which we're multiplying or we're growing or decaying, I need to figure out, hey, what did I multiply to get from here to here, from here to here, from here to here? It should be the same thing each time. And if I can't just see that that's 3, then I could say, well, 12 divided by 4, and that gives me 3. Or I could take 36 divided by 12, or I could take 108 and divide it by 36. You would get 3 on each of those. Okay, you take one of these and then kind of divide it by the one right before it. So my equation in that y equals a times b to the x format would be y equals 4 times 3 to the x. Next, y-intercept. Well, it's where x equals 0. It's your initial value. That's 81. Your rate is what you're multiplying by each time. And once again, we said, hey, if I don't know what we're multiplying by, I can start with 27 and divide by 81. Now, this is going to be a little weird because when I punch that in my calculator, it tells me 1/3. I would just double check that with each of those and make sure, okay, 27 times 1/3. Yeah, that equals 9. 9 times 1/3. Yeah, that equals 3. So 1/3 checks out. So my equation would be y equals 81 times 1/3 to the x. That's one of those decay functions. The numbers are getting smaller as x increases. Last example right here, and it's just a little bit different. Why is this one different? Because it starts with 1 as my x instead of 0. So I don't know what my y-intercept is right now. I could tell what my rate is. I could say 20 divided by 5, that equals 4. Or 80 divided by 20, that equals, or 320 divided by 80, that equals 4. That's my rate. But I got to figure out what that number is for my 0 term up here. So if I'm multiplying by 4 going this way, times 4, then if I was going this way, I would divide by 4. So I'm going to take 5 and divide it by 4 in my calculator. And that would give me either 5/4. You could either write it as 5/4, or you could write it as 1.25. Either of those is correct. And so you would have y equals 1.25 or 5/4 times 4 to the x. Both of those are correct. You could write it as y equals 5/4 times 4 to the x as well.